So what we're going to talk about here are predicting products. In order to be able to predict the products, there's a few things you need to be able to do. For our purposes, for a first-year chemistry course, we aren't going to predict every single product that could form. Sometimes when we predict the products, it might not be what actually happens. That's kind of an upper-level chemistry context. So if you go on to take AP Chemistry, that'll be something you talk about. So what we're going to do is we're going to be taking a look by first identifying the type of reaction. Then we're going to write out our reactants and predict our products based upon our knowledge of the reaction type and the reactants. So just like when we're writing out the reaction from a sentence, we want to make sure all our compounds are balanced, and then we're going to balance the overall equation. So you're not balancing, you're balancing two separate things. You're balancing the compounds as well as the entire equation. So in the first reaction here, we have hydrochloric acid, HCl, reacting with sodium hydroxide, which is NaOH. So I wrote out my reactants. Based on my knowledge, I have two paired things. This is going to be a double replacement reaction. So in a double replacement, you switch the partners. You're going to end up with NaCl plus H2O, which you kind of have HOH, but H2O is another way to say it that we're more used to saying. Now, taking a look at this, now with the double replacement reaction, one of the things we have to do is we have to check our solubility chart to see if we have formed any precipitates. So we've made water, which water is a covalent substance, so it is a liquid. So that is formed. In order for the reaction to occur, you need to form something that's not aqueous. So you either need to form a precipitate, which would be the solid suspended in the solution, or you need to make a liquid or a gas. So in this case, we're making a liquid right away, but we can check the solubility of the other things in our solubility chart to see if there's any precipitates. So if we take a look, we had hydrogen and chlorine, it's soluble. We had sodium and chlorine, which is soluble. And we had sodium and hydroxide, which is also soluble. So we have all soluble things, so all of those are going to be aqueous. So we'll have AQ, AQ, AQ. Now, this is something we need to do for double replacements. Other reaction types, the solubility doesn't play as big of a role, and if you need to, the problem will specify. So in the next one, we have sodium reacting with oxygen. It's O2 because of Brinkelhoff. Based on the information we know, this is a synthesis reaction. We have sodium and oxygen. It's going to be a synthesis. We have two things. They're going to become one. For our purposes, which is Na2O, for synthesis and decomposition, we're only going to have basic ones that we predict. So we have two elements becoming a compound, or a compound becoming two elements. We're not going to, there are more complicated ones where you form simpler compounds from a more complex compound. For us, we're not going to worry about that. So the next one we have mercury 2 oxide, which is HgO. We have one thing, this is going to be a decomposition. We have one thing breaking into multiple. So just note, in reality, you can have more complex synthesis and decompositions. You may see them in a full example. You will not have to predict products or of those. Next up, we have zinc reacting with lead to nitrate, which is PbNO3 2. So this 2 is balancing the nitrate's charge with the lead. The 3 is what makes it nitrate. So nitrate NO3 is a polyatomic that we're kind of used to seeing. So what's going to happen, zinc is a metal, so it's going to replace, it's a single replacement. The zinc is a metal, it's going to replace the lead. So we'll end up with ZnNO3 with a 2. So zinc also has a +2 charge. Zinc is one of the elements that only has one possible charge, so it becomes Zn +2. And then we're going to be left over with lead, which is Pb. And then the last example, we have methanol. I'm going to rewrite it as CH4O. So I'm combining all like elements together to make it easier to balance. Reacts with oxygen. So this is a combustion reaction. We have an organic substance with carbon and hydrogen reacting with oxygen. That's what makes this a combustion reaction. So we have that. We're going to then form the same thing. We're going to form carbon dioxide and water. All combustions form carbon dioxide and water. Now, we do need to make sure we're balancing these. I think we forgot to balance 2 and 3. So in order to balance number 2, right now we have 2 sodiums and 1 sodium, and then 2 oxygens and 1 oxygen. So it's going to be a little tricky. I need a 2 there to balance my oxygen, which gives me 4 sodiums. So I'm going to put a 4 in front of my sodiums. In the next one, it's a similar type problem. The nice thing about when we predict products, because we're forming simpler products, balancing it's usually pretty straightforward. So we'll need a 2 there and a 2 there. Number 4 is actually balanced already because because it's lead with a +2 and zinc with a +2. Now, if you had lead with a +4 and zinc with a +2, then you would have to do more to balance it. But that's a more simplistic reaction. And then this one, combustions are always a little tricky to balance because of the carbon, oxygen, and hydrogen that you have. So we have 1, 4, and 3 on the reactant side, and 1, 2, and 3 on the product side. So right now, hydrogen's the only thing not balanced, so I'm going to put a 2 in front of hydrogen, which gives me 4, or 2 in front of water, which gives me 4 hydrogen, and now I have 4 oxygen. Well, now I have that odd-even problem, so I'm going to put a 2. Quite often in these problems, you do need a 2 in front of the CH4O. So if you think that it's not going to work out, it's a good idea to have that 2 there. So that changes carbon to 2, or hydrogen to 8, and oxygen to 4. So now I need to go back and balance my carbon. I'm just going to hold off balancing my oxygen until I fix my hydrogen. So I have 4 plus 4, which gives me 8 oxygen. So then I have 2 here, so I'll need a 3 here to give me a total of 8. So you have to be careful when you have oxygen in your organic compound because you have to count that oxygen as well as the oxygen here. I wanted to take a look at a few more double replacement because this is kind of the harder part. With a double replacement, predicting products can be a bit tricky because you would have to take a look at the solubility table. So we have silver nitrate, which is AgNO3. Silver has a +1 charge, nitrate has a -1. Reacts with calcium chloride, which we actually use today in our lab. Silver nitrate and calcium chloride are going to react to form, well, as I kind of alluded to, this is a double replacement, since we wanted to look at a few more examples like that. So our metals are going to switch places. We'll have AgCl plus CaNO3. Now, because nitrate has a -1 charge and calcium has a +2, I need 2 nitrates to balance with the calcium. So right now I have balanced my compounds, but I have not balanced my entire equation. So in order to balance my entire equation, I'm going to have Ag, I'm going to have NO3, Ca, and Cl. So I have 1, 1, 1, 2, 1, 1, 2 nitrates, and 1 calcium. So I'm going to start with the nitrates. Gives me 2 silver and 2 nitrates. And I'm going to put a 2 in front of AgCl. That gives me 2 silvers and 2 chlorines. I now have a balanced equation. I just need to determine my phases. So we're going to take a look at our solubility chart. So on our solubility chart, we had silver, which is right here, nitrate, which is soluble. We also had calcium chloride. Generally speaking, your reactants are going to be soluble. It's going to be the products that generally are going to be if you have a precipitate form, that's where it's going to form. So we formed, we're going to change to red, calcium nitrate, which is soluble, and silver chloride, which is insoluble. So we have formed silver chloride. So as I said, we have an aqueous, solid, and aqueous. As I've said previously, the solubility chart is not something for our purposes that we need to memorize. It'll be provided to you. It might not have all the information that's on this one, but it'll have most of it. But then we have our entire reaction. So when we have something like the silver chloride that's a precipitate form, the reaction is going to take place. If you don't have a precipitate or a liquid or a gas form, the reaction, nothing is going to happen in the reaction. So in the lab that we did today, you saw some of them, it looked like nothing happened. The solutions looked clear. You didn't see any solid. You didn't see any bubbles form. You didn't see anything. Sometimes that happens. So what you're going to do in the lab is you're going to go through and write out the reactions. If the reaction happens, you don't have to do anything. If the reaction doesn't happen, you're going to write NR for no reaction.